versioning strategies. Again, this is again strategies. We have addressed the versioning patterns, approaches, now the strategies. So there is no one versioning approach that is right for everyone. So there is no W3C standard or W3C convention that this is the best versioning approach. Versioning approach even applies to the coding, the development that we do with the regular development activities, right? We version our code, we use the SVN or CVS or Git for versioning our code, right? We baseline the code. So versioning is a very universal thing that we do, and there is no hard and fast guideline for versioning, depending on how anyone wants to do those versioning things, right? But there are still few concepts which I want you to understand, and we have covered because they are very important concepts. And in this section we are going to single out the following 3 known strategies, but no one knows. We cannot say this is best or this is worst, right? So what is the strict? So these are 3 strategies: strict, flexible, loose. What is strict? Just understand in one word, that if it is example, just focus on the example, new change, new contract. So it will be not backward compatible, it will be not forward compatible, it is just a strict example. Now I want any one of you to give me one example of strict versioning strategy so that we can move forward with the flexible. Just one. Maybe I can help you with a strict example, which is a 4G implementation by the telecom operators. Initial we had 3G, now we had 4G. So 4G is a completely strict versioning strategy, that whatever 4G services have been developed by AT&T or T-Mobile in US or different parts of the world, different telecom players, they are all strict. They are all new. They have new infrastructure. They support the new protocols. So whatever is there behind to support them is all new, and there is no guarantee that it will support the 5G protocol or the 5G technology, which would be evolving somewhere around in 2018, right? So it is strict example. This is an example of strict. Now come to flexible. Flexible is, you say that there would be a backward compatibility but no forward compatibility, right? So Raghu says smartphones versus the old mobile phones. Raghu, can you be a little specific here? So this is the example for flexible which Raghu is giving me. Maybe you guys can give me some more examples. Strict. Oh, okay, you are giving me this example for strict smartphones. Yes, to some extent. But if we take an example of Android, that the different apps that we have on Android, sometimes they also work on the lower version and the higher version, right? Okay, so flexible. What could be the example of flexible? If I give you a very good example of flexible, because this is I have to think at runtime. So if you have heard about the USB port, right? If you heard about the different apps, the Android apps that we have, so there are instances when they are backward compatible, right? Let's say a USB port 2.0 or a USB cable 2.0 would be compatible with the different older USB versions, or the HDMI lead. Let's say you have a HDMI port and you have a HDMI lead. So the HDMI cable would be compatible with the older HDMI ports as well, right? But it will not be compatible with the upcoming HDMI port, because it says until HDMI ports 2.0. So just it could be any example, right? So, and the other example for flexible is, if you guys have used TeamViewer, this is one of the desktop sharing softwares, because this is my personal example, that if you have TeamViewer, then I would be able to share my screen with the less version of TeamViewer. which you have on your machine. But if you have a higher version of TeamViewer, we would not be able to share screens with each other. So they are not forward compatible. I'm not sure if you guys have heard about the TeamViewer, but this is one of the examples which I know does not work with the forward. So now what could be the example of loose version strategy, which works both ways, the forward and the backward. I'm not seeing much of the examples coming from you guys, because I mentioned at the start of the class, this content, we all knew about it. We just have to realize that this all can be fitted with respect to versioning. So a loose example could be the Microsoft 2013 example which I gave you, right? So MS Word, exactly Raghu. So Raghu is saying MS Word example. So most of the softwares that we use today, they are loose examples, right? Loose version strategies. So if we know the concept by example, then probably we need not need to know by reading the theory around it, right? What all point, because we know. So there are few points which are mentioned about the strict strategy: new chain, new contract. There would be no forward, no backward, and I don't think there is anything else. The super strict approach is not really that practical. So it says it is not very practical because you cannot stop everything at once, and you can ask because everything has to be new. But with the 4G example which I gave you, is actually these examples have to reinforce that everything which is existing dies out except for the business logic, because these are very emerging technologies, very high focus technologies which requires a lot of change, and these technologies are very strict technologies, strict version techniques, because nothing which is prior use, even you cannot use a 3G phone which you have for the 4G technology. So that means it is strict, right? Your phone is a consumer for a 3G technology. Now 4G comes and you say it is not 4G compatible, right? So this becomes a 3G strict versioning technique. I hope you enjoyed these examples, right? So for every versioning technique that we discussed, we have the pros and cons, and if we can think of the examples, then we can very well understand what could be the pros and cons for each, right? So strict would be the most non-acceptable thing, and the best would be the loose because it has forward and backward, and the medium would be the flexible that we saw, right? Because it has the backward but it does not have the forward. So we are discussing the pros and cons for each and everything. Okay, so after discussing the pros and cons for each and every approach, now we see a very interesting matrix which I want all of you to see, and just give some moments to this in understanding, because this is a very interesting matrix to know. Now we have seen 3 versioning strategies: strict, flexible and loose, and we will not just leave these strategies here itself by just knowing them theoretically, example and pros and cons. We will see one more insight around these strategies which will actually help the service designers and architects in assimilating, in making sure how to analyze and how to gauge these strategies, and the decision which these designers will take based on the strategies and their different characteristics. So we have already discussed the strategies, but the new thing which you will see here is the characteristics: strictness, governance, impact and complexity. So we'll understand, we already knew what is strict, flexible and loose in terms of versioning strategy, but now we'll try to understand what is these characteristics. So I'll just walk through with a few points around each characteristic. The rigidity of the contract versioning options. The strict approach clearly is the most rigid in its versioning rules, with the loosely strategy provides the broadest range of versioning options due to its reliance on wildcard. So what these points are highlighting, that strictness. So I mean the rigidity of the contract versioning option. So this is a very rigid, the contract is very rigid, that it has to be like as what it is being decided and mutually agreed upon by the contract, the service provider and the consumer, right? So it is a strict, right? It does not have a backward compatibility. It does not have a forward compatibility. It is something new, and it will remain there because the strict approach clearly is very rigid in its versioning rules. This is the property. So it is what it is today, and there is no surety whether it will be forward or backward. So what is the probability of this? The characteristic is high, right? And for medium, let's say you have to decide on the medium flexibility. So it will be medium and low. So now you have to understand from this table what is mean by high, medium and low. Can any one of you can tell me like what is meant by strictness as strict high and flexible medium and loose low? Let's not talk about the governance, impact and complexity for now. Just focus on the first line. What do you mean by strict? Strictness, strict as high, medium as flexible as medium, and loose as low. If any one of you can help me in what is your interpretation so far? Only on the first row. Okay, Raghu says ability to use existing services with new service. Yeah, to some extent Raghu is right. Any other, I only see responses coming back from Raghu. So if any one of you can also try. The allowability of an existing web service client to use a new endpoint. Yes, to some extent this is also very true. See slide 57. Even I don't remember the slide numbers. Right, so the concept is coming from slide number 57, because in slide number 57 we understood that strict will be altogether new version, new change, new contract. So strict and flexible is both forward and the backward compatibility. So for flexible is any incompatible changes result in a new version of the service, and the contract is designed to support both backward compatibility and forward compatibility. Okay, no worries. Yeah, I know, I understand it takes some time. So it actually takes some time to settle down and to understand this matrix, that when we say this is the property, this is the strictness. So when we say strict, and we have the strategy for designing and versioning a web service with strict, so the strictness is always high because it is rigid in its versioning rule. But flexible can have both forward and backward, right? The flexible can have only backward. So it is medium. The strictness of flexible strategy is medium. It is not very tough. So the developer, the service designer will only have to take care of the backward. They will not have to take care of the forward. So it is medium. But loose strategy is it will be both loose, it will be both forward and both backward. So strictness would be low, right? They don't have to worry about the strictness because it is both ways compatible. So there is actually the strictness in terms of versioning rule is very less. It is both ways compatible. So high, medium and low. Now we'll move to the governance impact. But before we do with the government, we have to understand what is government impact. The amount of governance burden imposed by a strategy. Because these are some real examples. This matrix will actually help a service designer or an architect to take a decision, right? Because they also take decisions based on certain guidelines, certain experience, and certain characteristics. And what are the characteristics? They are like more than 10 characteristics, but all those 10 characteristics are actually grouped under these 3 principal characteristics, which are strictness, governance impact, and complexity. So what is governance impact? That there is a change which has a big governance impact. Both strict and loose approaches increase governance impact, but for different reasons. So if I go back to the matrix, so strict will again be strict because it has a huge government impact and it is a new. Flexible in all cases would be medium because one has to take care only of the backward compatible changes and not forward. But what will be the loose? Why it is high? Loose is high, loose strategy is high because it also has to take care of the forward compatible changes in the near future. So the designer, the architects will have to take a lot of assumptions that what all technologies would be coming in near future so that their services will still be able to be used and there are no assumptions, right? Whatever assumptions that they take will be used. Let's say now I want to give an example here. Guys, can you still hear me? Because there was a small power outage at my home. So, okay, great, Hugh, thank you. Okay, so now I want to take an example here because you understand the government impact very clearly. In telecom industry or any industry, there are so many regulations which always keep on coming. Let's say I take an example of India or US. There was a regulation change that the mobile numbers that we use should have the capability of portability. That a T-Mobile number, if a end consumer can take this number to AT&T or vice versa. So this is a regulation change, right? Now, T-Mobile or any telecom company will have to make changes in their infrastructure, in their services, so that Verizon customer can come to AT&T and AT customer can go to T-Mobile, all that. So they have to think well ahead for next 10 years or 5 years that whatever other regulations that will come, and let's say in near future, if US government allows the portability for US Canada numbers or all across US numbers or different, right? It could be any business case. So their visibility, their thought process should be so aligned so that they can also these changes can also make sure that they would be forward compatible. I hope you got my point, the example which I gave you, because this is some live situations which I have been working for years, that I was supposed to create a service. We were supposed to introduce changes in one of the mobile app operators that we were working on, and we have to change the services for the roaming services, that a person in Romania can take the roaming services and go to some other country in Europe, and it was related to some time zone related changes. So that was a government's impact change, which was the loose strategy type of versioning for us, right? So again, now we are just left with so Hugh is saying yes. Okay, so now just try to understand the last, which is complexity. So here, whatever that you are supposed to do has a lot of complexity involved, and due to the use of wildcards and unknown messages data. So when we say complexity, we do not know what could be the message format, what could be the complexity in terms of the security that would be involved. So complexity could be in terms of anything, right? Technology, data, requirements not clear. So now if I go back to my metrics, so the complexity is high, and you still have to do a strict kind of a versioning. again it will be very low. Why low, why not high here? Can anybody answer that? Why it is low and why not high? Because for government's impact and strict it is high. Why it is low for complexity? I'll just wait for a couple of answers and we will go to the flexible, that it will again remain medium because it will just have to support the backward in case of the complexity, backward compatibility. But in case of loose, it will again be high because the government's impact or the complexity. The example remains the same because the technology is not clear, the future technology is not clear, the future regulations are not clear. So the loose strategy will always be high. Now we are just left with one question that I just brought up, that why for complexity the strict is low. If anybody wants to try this, I'll show you the points for compare. Okay, I sometimes have to check my current system time, that when did you actually ask this question. So it is low. So it is low, complexity for strict is low because you don't have to worry about any versioning. Okay, this is for strict, but why for complexity? Okay, to some extent it is correct. So why I asked this answer from you, this complexity strict strategy, when your characteristic is complex and your strategy is strict, right? So because you have a strict strategy, so if it is any change, you will just deploy anything new, and you know it is complex, right? So this combination, this cell, and the value, be it a high or low, is always subject to a big discussion, and this is very much under discussion between different communities who share these matrices and who actually create these metrics, that in some of the cases it is found it is low, and it is some of the cases it is found it is to be high. So this is subject to lot of situations and assumptions, and this is always being under discussion between communities who work on these strategies and designing these matrices. So even I assume that this could be low or this could be high. So this is always subject to discussion, and this is always a kind of a disputed value. So, but if you ask my assumption, I assume, my perception say the value of this should be high, right? But if you go and refer to the books or the content, it still says low, and it shows a star against it based on the conditions. Right, so Raghu says it could be low because in terms of the overhead of maintaining the compatibility issue. Yes, this could be one reason. But if we talk about the complexity, since it is complex, so again, it can lead to high. But yes, since there would be no compatibility issue, that can be the only and sole reason that it can be low. So this is all that we discussed about the different concepts that we had in terms of patterns, versioning, different versioning types, changes types, minor and major changes, backward and forward compatibilities, and the different patterns that we discussed, the different solutions, the combination of proxy services and ESB services. And this slide is just quickly go through. Sometimes you will see more detailed version like this, 2.0.1.1. So I just don't want to skip this concept, that what happens that these are all, because they could be in real life products. Even this can answer to what one of the people was asking earlier, that can we have examples. So even when we see these complicated versioning terminologies 2.0, 0.1, 1.2, so what this means, that there are different teams who are working on different integrations of the same project. So this 0.0 could be related to some different functionality of the project, and another one, this one, the next one after 0.0 could be the another version, another aspect of the product, and different teams are working all together. So maybe for O version, this concept could be very new. It might have been introduced for the very first time in the project, and 2.1, 0.1, that means there could be a possibility that this product version has this functionality coming at this for the second time, right? That is why we see such complex version numbers for big products like we have from Microsoft or Adobe, or maybe some browsers, or maybe the Red Hat Linux versions that we have. So they are very complex because they have so many different inbuilt modules that they have, and that is why it is the version convention becomes a little complicated. Now just one more example. A major version is generally expected to break backwards compatibility with programs that belong to other major version. This means that program version 5.0 is not expected to be backward compatible with 4.0, right? So this is all what the versioning and it is all about. So now we just have one last exercise to look at, because we always see some concepts, and the very next moment we see some exercise around it, so that it actually we understand it better from a real life standpoint. So problem statement is, as a provider of the service, one is obliged to maintain different version of the service. This is a very common requirement for any service related infrastructure. One of the possible reasons could be the existing customers of the service doesn't want to upgrade to the newer version. So consumer doesn't want to upgrade because let's say they don't have the IT support, their IT vendor is still no more with them, or for any reason. Given the above problem statement, the service provider would need to imagine and maintain multiple execution path, request, response, structure objects. Yes. So what happens? This usually happens, right? That if you have multiple versions running, that means eventually you have multiple request, response and media types, permutation and combination available, and which creates complexity. So what to do next? Looking at the above problem statement, this clearly seems to be a problem related to REST API versioning. Let's assume, right? Because now we are focusing more on the REST. So what we'll do? So you will understand that, and this is what few of you were asking, that can we see some examples? So this is one of the examples that will help you to some extent. So what is happening here? That now what will you do? You will again bring your Spring MVC, Jackson API, and you will write some service, right? Now let's say you will build two versions of the service, version 1 and version 2, right? So this is for one of the person who was asking me earlier that how they can see. Let me just pick the name. This is for Mandy. Maddy, maybe if you can just follow me here for a couple of minutes. This can answer as what you were asking. Can we see some live examples? So this is one of the coding examples that we have, right? So there are two versions of service, version 1 and version 2, right? And what is this service all about? That this is a service about fetching the employee details by giving the employee ID or the employee name, and the service will send you back the employee details. And what would be those employee details? It could be employee number and other details of the employee. So now you see a bean class, a model or a Java Pojo here. So what is happening now? So we have created, so typical nature of implementation is we write another service, the second service, and expose that to the new customer. That means you will have different clients. Based on the problem statement, the solution proposed below would introduce a seamless versioning of your REST services on JSON. Perfect. So now we have exposed two services. One is version 1 and one is version 2. Now let's try to understand what is the difference between these two services. Let's try to move ahead. So what is happening? So I hope you remember this request mapping annotation that we used for writing REST web services with Spring MVC. And this similar annotation was something else when we use the REST template, right? So this is the ID which you will pass, and now you have given a version. So it says this mapping, this controller class will work for version number 1 and version number 2, both. Because what will happen, your client will send you a version number in the accept attribute which we saw earlier, right? Accept colon version and the data format, application/JSON or application/XML or whatever else. So now these two snippets of code tells you that if you write include version point, the version number, right? This dot means this list, you can mention list of version numbers like we have mentioned here. So this means that include property for given versions of the service, and exclude mean exclude property for the given version of the service. These are little coding related and technical terms, and I assume there would be some of you which may not follow, but I'm just trying my best. So what is this second version web service is doing? So the requirement is that first web service version number will send, you will send the employee ID and employee name, and it will send you some employee primary number back to the client. And in version 2, what is happening? That the client will still send the employee ID and employee name, but in the response it will get one additional field which is secondary number. And that is, this is the importance of this annotation. This says if the request version is 2, please include this attribute in the response, which is the get, right? The getter means you are getting the value. So this is the difference between these two versions of service. So this is the version 1 of service, which does not says anything. It is it exists at a point of time where there is no version 2, right? So it is just taking the, I'll just go to the next example here in detail. So what is doing that, I just have to go back, that this is the example where a search is being done and employee detail is being asked, right? Since there are no versions, there is no version number which is being passed in the request, right? But now when you introduced a version, now you have two versions. So what you will do, in the get employee detail method, you will introduce some parameter. It says query param version. So the client will now send you the version as well. If you remember, we saw one of the examples, except application JSON version equal to 1 to whatever. Okay, so in the previous version, when there was no other version, you will not see any query param, right? Now since there are two versions, the client will have to send the version. And what this query param says, this is a version number coming from the request in the URL itself. And it says the default value of this query param, this version is considered to be 1. So it is assumed that the second version, the new version is version 2, and the old version is deemed considered to be version 1 by itself, right? And similarly, we are sending the employee ID and employee name in both the cases. So now what will happen? See the difference. So what is happening now? I'm trying to show you the exact complete method, not just the signature but the implement. So I have put a switch statement here, switch version. If it is 1, then it says show invalid data. And if it is else, that means if it is not 1, then return the entire employee object, including the field which was employee some secondary number, and it has the annotation @include version equal to 2. So this annotation at runtime will say to the compiler, if it is version number 2 request, please include my attribute as well. If it is version 1, the model or the bean, the POJO will not include that particular attribute at runtime. And also now if I see this if statement, if case equal to 1, so it has stopped, it has disallowed any client sending any request from version number 1. It says if it is version number 1, please send the exception to the client, say invalid data. Please send me the new request. Please send me the version 2 request. But you can change this if statement and you can again send the result which you are seeing here in line number 21. If I copy these two statements 20 and 21 instead of this throw new exception, then what will return to the client? The employee details will be returned to the client. The only attribute which has this @include annotation will not be included in the response. So this is the this is why I intentionally shared this code example. This is a working code example with you so that you understood and you are very able to understand easily that when this version actually comes in picture, then how this interaction happens in REST web services, right? I hope you understood this example, and this is for the second method, right? So this is all about this session, and as far as the time goes, we are just 5 minutes left. I just go back to Dell's question. Sorry Dell for keeping you wait for this for my response. Really apologize for this. Can you discuss advantages and disadvantages of expressing version requirements as a part of the URI versus as part of except header? If I just go through this question, probably I just have to read it out once again to be very clear on what we are trying to ask here. Let me just read it once for all of you and for me as well. Can you discuss advantages and disadvantages of expressing version requirements as a part of a URI versus as a part of except header? So Dell, so what I understood, if you are, there are the two things which you are asking, that sending the version number in URI or in the except header, they are exactly the same. If you send the URI, right, to access the resource, so you will say ver version equal to 1 in your URL, let's say in the browser. Now this ver version equal to 1 which is coming in your URI will actually be in the runtime, it will be mapped to your attribute which I showed you in the code, this version. So whatever this version value is coming in the URI, this version will be substituted here because this is a method and this is a parameter. I hope you got my point. So they are same things. And if you will not send with except attribute in the request, it will not be loaded here, right? So what will happen? You will send it in the URI with the help of question mark version equal to 1. Your client will construct a HTTP request for it internally and say operation get accept application JSON comma semicolon version equal to 1, and it will send to the producer. So this is some internal construction which happens before the request actually comes to the HTTP server, which is your producer. I hope I am able to explain your doubt well, and please help me with a yes or no. Now there is one question coming from you. Is that version obtained from the HTTP header or from a URI? Okay, Dell says Thank you. Thank you, Del, for asking this question. And I hope you got a very good clarification of this. Coming back to the Hugh, is that version obtained from the HTTP header or from a URL query string? Again, this is a similar question to what Del was asking. The client will send it either, so the client has always the options of sending it both ways. So just try to understand, your client could be your Chrome browser. That could be your client itself. You may not have any other client to access. When you access flickr.com, who's your client? It is your browser who's your client, right? You are not creating any additional Java client or REST template client. Your browser URL tab is your client. So when you send your request with a browser, your URL is your client, and this will be internally mapped. It will create some construct and it will send to the provider. And if you are using it from an application, some internal application will fire this flickr.com, right? So the application will create this construct. Get operation @get accept application JSON semicolon version equal to 1. So the URI or what this client is creating, REST client, is exactly the same. For I hope Hugh, you understood it well, because the question which Del and Hugh asked were exactly the same. Please respond me with a yes or no so that we can gracefully exit this class and we can wrap this session up. So in just next 1 minute we would be completing our time. Well, from what I read, query param only gets value from the query string. No, it's not like that the version can only be coming from the query string. No, because when your client will access this, it will say, let me explain you. This you rightly pointed out, and you should understood it, that it is not a query string, and if it is coming from the client will also internally map it to a query string, right? Because the interpretation will have to be same in both the cases. And this piece of code which you are seeing on your screen, slide number 75, will get this version number. Either it is coming from a HTTP client or it is coming from a query string. Because if the client will not get this, then you will always have the limitation that you can only use this service from your browser or by introducing a query param, which is not the case. Right. So I hope you guys enjoyed this session, and Mendi, I hope the examples, some code examples which you were expecting, we have covered 3 examples in this session, just to make all of you understand that rather than just talking in terms of theoretical, that what is versioning, backward, forward, types and types of changes, backward changes, non-backward changes, forward compatibility, the patterns that we discuss, client bind pattern, adapter pattern, the ESB solutions. We just try to give you example of all these concepts that we discussed related to versioning with the help of some code examples and some pictorial representations. So I hope all of you that you enjoyed this session.